As an example of what happens to tensors when the input shape changes, say for example, we have a tensor flow that looks like this. So tensor flow that looks like this. The first one is T1, tensor 2, tensor 3, tensor 4, tensor 5, and tensor 6. So our information flows in. So this is our input, and information flows out from the bottom. So this is output. If my input, let's say, has a shortened shape S1, then my first tensor accepts this input shape S1, and then the tensors after that automatically adapt to the same shape S1, so that all the tensors adopt the same shape. The question is, what happens to the other tensors, the tensors that are attached to the first tensor when the input shape changes? Say we have a basic neural network model that looks like this. It accepts tabular data. This is a sequential model. We'll talk more about this in future lectures. And say I have a dense layer with 12 neurons in it. It receives 8 columns. That means my input data looks like this. My input data has total 8 columns. This is my column 1, column 2, column 3, column 8. So we have 8 columns, and then we have, we don't know, maybe a few hundred rows or something like that. And these 8 columns feed into, let's say, a neural network with 12 neurons. So each of these feed into 12 neurons. So basically, these 8 input columns feed into 12 neurons. So we have 12 neurons in the second layer, and then 8 neurons in the subsequent layer, and then 1 neuron in the last layer. So if I want to draw this visually, then in my first layer, L1, I have 0, 1, 2, all the way to 12 neurons. And then all the way 8 neurons in the second layer that all connect to all the layers in the first. And then 1 neuron in the last layer. And all of these receive input from my tabular data. So now when we have a neural network like this, let's look at this visually. That is, say I put the number of columns, that is these 8 columns in this dimension over here. So we have n cols equals, this is 8. And then let's reserve this, this dimension to the number of columns. And let's reserve this dimension to the number of samples, as we can see here, number of samples n. That is, how many samples the neural network accepts at one time. We can also call this batch size. So batch size. So we have number of columns in this axis, and then we have sample size in this axis. Now what's left is the height, that is how many neurons we have. So in the first layer, we have 12 neurons, so first, second, third, fourth, all the way to 12. In the second layer, we have 8 neurons, so we have total 8 neurons, 8 rows here. And then finally, we have only 1 neuron, so 1 layer at the end. So even if we just have 1 neuron, the height of these tensors, so this is my first tensor, let's say this is T1 and T2, and let's say this is T3. So for T1, the shape of the tensor will be 12, and then the number of columns C, and how many samples that we have at a time, n. Similarly for tensor T2, its shape will be 8, C, or maybe in this case, actually, it may receive, it doesn't necessarily need to have C columns, because now in the second layer, actually, it's instead of C, this will actually be 12, because it's receiving 12 inputs from the previous neuron. So it's 8 times 12 times the number of batches n. And finally, in the last neuron, the dimensions will be 1 times 8, which is the number of output it's received from the previous output, times n, batch size. So the point here is that depending upon our number of column C, which is specified in input dim, and our batch size, that is number of samples n that we provide as input to the network, C and n, the rest of the tensors, so for example, this is my first tensor, second tensor, third tensor, all of them adapt automatically. So data flows from the top, goes all the way down, and then comes out from the one neuron at the end.